Well, hello, everyone, and thank you so much for joining us today as we continue our webinar series. And today we are talking about engineering and a career in biomedical engineering, to be specific. We'd like to start by thanking the Ohio College Tech Prep organization for helping us to produce these videos. And we really appreciate having our guest today, who is Dr. Amy Dahl, who works at the University of Dayton as an associate professor in the biomedical engineering area. So Amy, thank you so much for taking the time to be with us today.
Thank you for having me.
We really appreciate it. And we're gonna dive right in and get to know a little bit about you and about what you do as a biomedical engineer.
Sure.
So tell us about it. Tell us, what does a biomedical engineer do? And how does that relate to your organization's success?
So as you mentioned, I'm an associate professor at the University of Dayton. I've been there about 5.5 years, but I've been in the field of biomedical engineering for over 25. So I kind of came to academia later on. I had a career in government for about 15 years prior to academia. And in terms of how my job relates to the company I'm currently working for, which is the University of Dayton and its success, you know, my primary job currently is to teach engineering courses and guide students in sponsored research. So it also entails almost running a small business, because we're supervising engineering laboratories and research portfolios. We're running research experiments, we're publishing results or presenting at conferences. And then another part of our job is, in order to keep things moving and keep the support going for the students, we are expected to procure external funding that does support the graduate students that are working on, let's say, a master's or a PhD degree. So the overall day-to-day operation of those laboratories fits into that as well. So my success is really measured in terms of the student success. So one of the things that I've really enjoyed having a background in biomedical engineering and coming to a university that doesn't actually have an accredited program in that or a degree track is to create new opportunities for students. So I mentor a lot of students in electrical and computer engineering, where I'm housed, but also mechanical, chemical, and materials engineering. And really, for those of them who are passionate about the field of medicine and really wanting to see if they can get involved, it's been very rewarding to kind of create those paths for students to be able to do research and then become employed in that field. So that's one of the ways I measure success. And I've been very fortunate to have this opportunity.
Fantastic. So working with students and helping them be successful is, is the way that you help your company, your organization be successful. All right. So tell us about a typical day in your life, in your position.
Well, first of all, you have to manage, right, being a parent and somebody who's working, right? But a typical day involves really a diversity of things. That's one of the things I really love about this job, is that I do have a little bit of freedom and flexibility to do something different almost every day. There are some requirements, you know, in terms of the classes that I'm teaching, or planning lectures, you know, grading student assignments and those types of things. I also do a lot of tutoring of students outside of class and meeting with them for academic advising and kind of planning their future out. I do a lot of, I would say probably that's half of my time. And then the other half of my time is working on research. So I'm in my laboratories, meeting with students to check in on their progress with their research projects. We're working as a team or a research cohort, sometimes with other students and faculty in other departments. One of the things that you'll find about biomedical engineering is it's a very systems-based type of engineering, and it's very multidisciplinary. So we're actually pooling expertise from electrical and computer engineering, as well as mechanical, chemical, materials, but also a variety of scientists from medicine, chemistry, biology, physics, anatomy and physiology, neuroscience, et cetera. And so I do spend a lot of my time networking and creating new opportunities So one of the things that I really try hard to do is infuse that same passion in my students, and also this idea of creating new pathways. Sometimes students are a little bit, I think, shy to kind of, especially engineering students, to kind of come out of their shell and collaborate. And I think that's one of the things that's really neat about biomedical engineering, is that you really can work as a team and gain that expertise from other people. So we do that. And then in terms of the research, part of doing research is publishing your work to share with the world. That's probably the funnest part, I think.
Awesome. So multidisciplinary, probably the most multidisciplinary of the engineering fields, it sounds like.
I think so, but I'm a little biased.
So you talked a little bit already, how long you've been with University of Dayton, about 5 years, and then been in the business, in industry, biomedical engineering for 20 years, I think you said, right?
Yeah, a little over 25. Yeah.
Okay. So good experience to, to relay, not just from an academic perspective, but also from a company and an employer perspective as well, in terms of what employers are looking for when they're hiring a biomedical engineer. And we're gonna get to that question. So what is that one thing that you really love? What gets you up out of bed every day and gets you excited about heading to work in the morning?
I would have to say curiosity. And that's also something that I look for in my students. So I'm definitely a person who likes to learn through experience. I'm very project-based with my teaching as well. And so I really look for students who are inquisitive, maybe don't know all the answers, but are willing to kind of take that risk and explore new frontiers. I kind of have this philosophy that when God gives you, a door, walk through it, or maybe run in some cases and explore it. And so I think the curiosity, and it seems to me that a lot of the students that I work with, along with curiosity comes initiative, and also creativity. So those to me are almost as important, if not more important, than perhaps grade point average. In fact, I have a number of students that maybe don't have, a 4.0, but they are absolutely inquisitive, and that leads to a lot of really interesting innovation. And that's kind of what is required, if you're going to create a new device that you want to commercialize to share with the world.
Absolutely. That is absolutely critical in so many fields, but it sounds like extra important in biomedical engineering. So tell me about your day, just in general, in terms of the number of hours or the percentage of the day that you're spending in meetings or working in groups, as opposed to working individually.
So I would say that the majority of my time is spent working with other people in groups, because I spend probably the majority of my time working with students. So either face-to-face when we're in the classroom, but I also am with students a lot of the time outside of the classroom. So I engage with them regularly within the research laboratories. And, of course, there's meetings. We all have those. I do participate in a lot of committees that are multidisciplinary, where I'm reaching out to other faculty members across campus or even in industry. But I would say probably 75% of my time is really spent working in a group setting or working with a team. There's always going to be time when you're sitting there perhaps grading an assignment or working on a computer program that's more isolated, but I also tend to be more of an extrovert and really do a lot of work in trying to engage the students to build those communication skills as well.
Awesome. So a lot of time spent on collaboration and working with others, which kind of gets to the point that you made initially about the the diversity of working with people in other fields as well.
Mm-hmm.
So talk to me about a challenge. What would you say is the biggest challenge in your position?
Well, for me, to be honest, it's time management. And this is a skill I think we all face, whether you're a high school student or a college student or, a professional working in the real world. For me, I get so excited about the research and the potential. Biomedical engineering, relatively speaking, is a new field. So if you look at the department I teach in, it's about 112 years old, I believe, at University of Dayton. So electrical and computer engineering, especially electrical, it's been around a very long time. But in terms of ABET accreditation of biomedical programs, really you see the first ones in Ohio in the late 70s, early 1980s. And so the field in general, we're looking at this sort of 40-year window. So there's so much opportunity to do something new and exciting in this field. So I tend to just love all ideas that the students bring forth. I was going to share a couple, I think, kind of interesting projects that we're working on, two just real quick ones, just to kind of give students an idea of what we're engaging in. So I have a research team right now that we're working on something that's cutting edge. It's very timely. We're doing 3D metal printing in titanium alloys. And basically what we're working on are lattices or scaffold structures for orthopedic implants.
Wow.
So this involves, expertise in biomaterials. We're doing machine learning algorithms to do what's called in situ process monitoring, where we're taking sensors and fusing all of that data together to classify defects. This is work in tandem with the FDA. So we are in dialogue with them. It involves mechanical engineering because we have CAD drawings and fixtures. We're doing materials testing. And we're also doing a lot of studies in tandem with our biology and chemistry departments. For instance, osseointegration experiments with bone cells and the application of electromagnetic fields and how that will produce perhaps a patient-specific implant in the future. So you can kind of get an idea that there's a lot of different steps in that process, but one of the things that we're trying to do is get away from what's more of a one-size-fits-all implant and patient-specific that's based on bone density models from medical imaging, and then fusing that with 3D printing. So, that's a kind of one example. We also have another one where I'm working on kind of a other end of the spectrum that's more on the electrical side, is that I'm working on some projects where we're extracting DNA and infusing that in cellulose tags for trusted electronics. So it's a cybersecurity application that basically ensures that the supply chain is legitimate for the military. So it kind of two different examples that kind of show that biomedical engineering can be a lot of different things.
Absolutely. And life-changing, it sounds like, which is really the exciting part, I would say, from my perspective, to be able to be involved in that and change someone's life for the better.
And that's really why I went into the field. I grew up with, my father was an electrical engineer that worked at Wright-Patterson and the Sensors Directorate for over 40 years, designing radar systems, for the military. And I kind of always, he always kind of teased me about, you should do the same thing. I said, no, I want to help people. I don't want to design, things that are used, otherwise. So that really is part of it. And at University of Dayton, we have a lot of the Marianist values that are kind of brought into our curriculum and our research. And that basically means engineering for the common good. So I also do some work with like Engineering Without Borders, where we work on technology. For instance, we have a low-cost X-ray detector project that we're working on in Malawi, Africa. So there's a lot of opportunity to really take your skill sets and do good, better humanity, like you mentioned.
Absolutely. And to me, that just sounds really exciting. So it sounds like then you've got multiple different work environments you work in, from office to conference room to classroom to laboratory.
Right. And I do a lot of work with industry as well. So I've set up recently a clinical internship for students interested in biomedical engineering. That's through Premier Health Network. So we're doing some work actually in the hospitals. We're working on some telehealth telemetry projects. And obviously that became very important during COVID and helping them roll out new technologies for remote locations. And that's just one example. So I tend to want to get the students kind of out and get those experiences and projects that really, they're not textbook projects. They're really, real life things coming from industry about problems that they need help solving.
Right. Real life challenges to solve, which I'm sure is very exciting for your students as well. So it sounds like based on what you said, you're probably not someone that is on call.
I guess that depends on if you ask my children or not.
We're,
Because
we're always on call there.
we're always on call, but no, I'm not required like a doctor to be on call. However, I care about my students deeply. And so around the clock, I will and have been available to them. So if they run into problems, I've helped kids change tires. I've helped them with their homework. You know what I mean? You're not really on call, but yet if you think back to how my success is measured through theirs, that mentorship kind of is very important to me.
Wow, that's fantastic. And I'm sure your students really appreciate that as well.
Mm-hmm.
So talk to us about your path. Talk to us about your education and experience that led to your success, both from an industry perspective and academic.
Sure. So the industry experience, I worked with government and also I would consider, working at Wright-Patterson somewhat, industry based as well. But I have 3 degrees in biomedical engineering, bachelor's, master's, and PhD. And in my current position, that PhD in engineering is really required for university professors in engineering. However, with a bachelor's degree, there's a lot you can still do, and especially on the industry side of the house. Like, for instance, I just placed a student at Hillrom, and they make hospital beds. Another student that did research in my lab ended up at GE Healthcare. So, there's lots of opportunities to kind of work in industry. I worked in the clinical setting for a very long time, both in hospitals and then also working in vocational rehab, which is a field where you infuse assistive technology solutions for people with disabilities who want to return to work or perhaps pursue an education. So I spent a good 15 years working in that setting. Over that time, I think I saw about 10,000 patients and worked my way into management at the state of Ohio level, overseeing some of those programs and helping improve the legislation, et cetera, that supports those efforts. But I really missed research. And so sometimes when you're in industry, I really enjoyed this idea of like, okay, you're creating a device, you're working on a team. And this is kind of something I talk to my students about. You're working with a multidisciplinary team. There might be 100 people. If you think about somewhere like, Apple, and you're working on an iPhone as an engineer, you might be on the user interface side. You might be on the battery side. You might be on, there's, the UL testing. There's all different possibilities. And so at a certain point, you might be focused on one project. And for me, I just get so excited about research, and I wanted to engage in more topics at a higher level and be able to give back, if that makes sense. So I kind of progressed into academia because I was kind of at that stage in my career where I was ready to kind of move into more of a mentorship role.
Awesome. And like I said before, I'm sure your students love having that mentorship available to them.
One other thing I was going to mention real quick, and I know we're probably running short on time, is that when you work in the field of biomedical engineering, now as at a bachelor's level in industry, it's not required, but as you progress through, especially if you're working in the public health sector. So I did spend a lot of time in government. The professional engineering licensure is then required. So when you're approving devices for the public, so that's just something else to mention and kind of put in the back of people's minds, is that is an 8-year process. So
right, that certification.
Right.
That you need to keep up with continuing education.
Yes.
And right. So you talked a little bit about this in terms of the what you would look for. What are those skills that you're really looking for? That curiosity and motivation to solve problems. Any other things that you can think of?
Well, I think you hit on the two that are most important to me, is the curiosity and the motivation or initiative. And so one of the things that I've noticed is that rather than me going to a student, them coming to me with that interest and that passion is the key to success. It's kind of a different approach, I guess, depending on if you're teaching a class and it's an assignment versus engaging a student in research that they're interested in that could potentially be a career path for them.
Right.
And so, you know, their initiative and curiosity are important, as well as, you know, some of the things I've mentioned: communication skills, being willing to work in a team, you know, those types of things. And sometimes, you know, taking a risk and kind of being able to think outside the box.
Right. Right. And it sounds like it's something that's really, you know, that ability to think outside the box to be able to solve problems is really critical in the
Yes.
field of biomedical. So we talked about a little bit about this, and I think I heard you say that probably curiosity is
Yes.
that most important skill. Okay.
For me, yeah.
So let's say you're sitting down talking with a student who maybe is discerning a career in biomedical engineering. What would you say? What would you say to that student?
Well, I'm always very encouraging. I have never turned a student away that has come to me with that discussion. One of the things that I think is super important is to gain some type of experience in the field that you're interested in. So whether it's through job shadowing, internships, I know I have done a few of these for like the regional STEM school and things like that, where, you know, students say, hey, I'm kind of interested in this, but I'm not really sure what all it entails. You know, reaching out to people who are willing to sit down with you and open up their research lab to you, for instance, or even if it's just a tour, just to really get you some hands-on experience in terms of what that really entails. I think that's a big thing. There's a lot of students who, if they're willing to you know, reach out and try to find those internships and opportunities, that they're very successful. And it also kind of, you know, it's not for everyone. You might decide that, hey, this is something that sounded really interesting, but after I had a chance to actually explore it, maybe not.
Right.
But yeah, I think, you know, the other thing I always encourage them is that it's very multidisciplinary. So, you know, if they're curious and they're willing to work hard, then, you know, there's a lot of other knowledge that you can obtain about different fields. And it seems to be that the students who engage in biomedical research end up being very good systems engineers. And that's some feedback that I've actually gotten from employers that have hired our students, is that they can see a very large, complex problem and deconstruct that into workable chunks. And that skill set is very useful in all fields of engineering. So, you know, I get very excited about it. And, you know, I think it's because it's so new, and to me, there's so many opportunities, you know, to contribute, that it's worth exploring.
Well, and, you know, I think that's what students are looking for too. They're looking for, you know, is there a professional that I can talk to who's really excited about what they do and is really excited still after 30 years of working in this field? I mean, you know, if you can still get excited after 30 years, that I think could really excite a student about following in that pathway.
Yes, and you see a lot of recent developments where, you know, we were just learning how to explore things. If you think back when, like, you know, let's say computerized tomography, you know, came about, and now, you know, fast forward just what's happened over those 30 years, it's amazing.
It really is.
And yeah, so it's a good field, and, you know, I will always encourage a student to explore it.
What about that same conversation with a teacher or a guidance counselor? I mean, you know, they probably don't know a lot about your field.
Sure.
Hopefully they watch this video. But what would you say for to a teacher or counselor who is talking with a student about biomedical engineering? What would you want them to say?
Well, one of the important things that I talk to students about when I go and do seminars to kind of encourage them to consider it is that it actually is one of the fastest growing disciplines of engineering. So electrical, you know, has a pretty high placement rate. About 44% is our current statistic that we're using, that says, hey, a student that's interested in engineering, 44% will go into electrical. But in terms of the growth rate, and a lot of this has to do with aging baby boomers and, you know, unexpected pandemics and all these kind of things, there is a huge growth. And so over the next decade, the growth in biomedical engineering is estimated to be about 70%. So that's faster than any other field of engineering. And the pay is actually, my experience has been that the pay is higher for students starting out, even with a bachelor's degree, are getting paid higher than other disciplines of engineering. And part of that is that it's multidisciplinary. Part of it is that, different pay structures. So for instance, if you get hired by a hospital or, a healthcare company, they may be paying a little bit higher amount because, there's a lot of things involved. And I think sometimes when you have insurance reimbursement in the mix, that sometimes increases the salaries as well. But the student that I was mentioning that we placed, she was a student that it was kind of an interesting thing. I did a seminar and she was a sophomore, and I just kind of did a seminar on some of the research going on, and just, I was new to the university and kind of talking about, hey, I would love to work with some students. And she ended up coming up to me after class and say, hey, I've always been interested in the field of medicine, but I'm in an engineering track and I never knew how to fuse those together. Would you be willing to work with me on some independent research? So I kind of took her into the fold, and she ended up finishing that and doing some work for her master's degree. She's the one that ended up working at GE Healthcare. She is the highest paid graduate of our department, historically speaking, starting salary.
That's fantastic.
I guess those would be things in terms of growth in the field and salary potential would be things as a counselor I would be interested in knowing.
No, that's fantastic. And actually builds up to a question. I think it might be the next one. So the career path, the typical career path, let's say for your young lady who went to GE Healthcare. So you're starting out as an entry level biomedical engineer, then what? What happens after that?
Well, in her case, she was given the opportunity, and this is an interesting thing. There are, and maybe I should back step real quick and say that, there's two sort of career paths for people who want to do biomedical engineering. One is that you would attend a 4-year college program from an ABET accredited biomedical engineering program. And these are universities that almost always have an affiliated school of medicine. So in the state of Ohio, that would be Case Western and Wright State, who were actually the first two in the late 70s and 1980s to become accredited, as well as now Miami, OSU, UC. And then the other track is if you go to another university who doesn't have a dedicated biomedical program, like University of Dayton, you can get engaged in biomedical engineering through other means. So for instance, in electrical and computer engineering, we have a minor in biomedical engineering. There's also a minor in bioengineering. And then in mechanical engineering, there's a minor in biomechanics. So you still can work in the field and gain experience, which is the thing that employers are going to look for in the resume. They're going to look for, what experience that you've had while an undergraduate, the types of courses you've taken, any internships that you've worked or co-op opportunities that perhaps were in the biomedical field.
Okay.
And I think that was the segue to, you were talking about the typical career path. And so I'm not sure if I answered that, but
yeah, no, I think that sounds, that's, there's basically two different ways to get into the field.
Right.
It sounds like. And then, in terms of the potential path within a company, obviously you're getting promoted, as a basic level engineer to an advanced level, and maybe even into management or higher levels of the research track, the management track, just based on what you want to do.
And that's exactly how I got my start. I was hired right out of grad school, very green, and fresh out of college, and started off basically, on a team. And I was given my assignments and, working on biomedical devices. And then over time, as you mentioned, you start to take on additional responsibilities. And with those responsibilities, you gain some seniority. And then eventually, in my case, I worked up through management at a local level, then a regional level, then a statewide level. And then when I was kind of at the ceiling, I kind of moved on to the next tier, which for me was academia and mentorship there.
Awesome. So now we get to the wages question.
Sure.
So, the young lady you mentioned, I think maybe on the higher end of the typical, But for the brand new graduate coming out of, with a biomedical emphasis,
Sure.
what would that be?
So some of the notes that I wrote down, and I did a little just research to make sure I was being accurate, but our experience recently has been that the starting salaries for students that are engaged in biomedical research, either as an accredited BME or working within that field in another engineering discipline, it is higher than some of the other disciplines, and usually somewhere in the range of $65,000 to $70,000 starting with a BS. The master's degree can push you up into that $90,000 to $100,000 a year range starting. And then of course the PhD is going to push you up even higher. So usually somewhere in the range of 125 to 150 in industry, probably a little bit less in government, but some of this is, depending on the demand in the market. So right now, there's students getting unprecedented offers right now because the field is very much growing. And there's even some of our past graduates that are working on, ventilator design and things like that were offshoots of COVID and unexpected things that just, the country's facing.
Absolutely. Definitely a time of opportunity for students, for sure. Amy, what didn't I ask you? Is there something else that you wanted to add, or did we cover everything? What do you think?
Well, it's hard to cover everything that I would love to talk about in this field in a short time. But I think if I wanted to add anything, I would say that if students are interested in this field, reach out. I'm willing, of course, to talk to people, and I can provide that contact information. I do that a lot. And so, as I mentioned, if you're interested in the field, reach out to people, learn about it. And see if it's a fit for you.
Fantastic. I love that. And that's really the message in general of all of our webinars. And that is, do your best to learn about the field from what you can, and then reach out to a professional like yourself and have a conversation, have a shadow opportunity. There's nothing better than that. And in a perfect world, an internship, because there's nothing better than getting that specific work-based learning experience.
And I think a lot of students are intimidated or nervous to approach somebody in the profession because they think that perhaps they don't have interest in that mentorship. But I can assure you that there are people that would love, especially people in education, because they're in that because they want to reach out to students. So,
right.
Don't be afraid to ask questions, I think, is one of the other things.
Yeah, that's a great message to end us on. Don't be afraid to ask questions, and don't be afraid to keep asking.
Right.
To make sure that you're stepping into a field that really is going to excite you for many years.
Yes.
So Amy, thank you again for your time. We really appreciate it. And one more shout out, of course, to Ohio College Tech Prep for helping us sponsor these webinars to get out to as many students as possible. So thanks again to everybody for joining us, and we look forward to seeing you on another webinar.